Right, everyone, we're going to be doing questions on how to find the highest common factor and the lowest common multiple. So I'm going to start with the first question. It says, the first question, let me try to zoom this. Okay. Is that clear enough? No? Write down the highest common factor between the following numbers. The first one is A, 36 and 54. B, 120 and 154. So I'm going to do only these questions. So what are you going to do here? You're going to write down the prime basis of 36, prime basis of 54, and then identify the highest common factor there. So let's do 36. What prime number? Remember, we're doing prime factorization. We need to find the prime numbers that can go into 36 without the remainder. So the first one is 2. 2 goes into 36 18 times, and 2 goes into 18 9 times, and then 3 goes into 9 3 times, and 3 goes into 3 once. So the prime factors of 36 is 2 squared and 3 squared. As it find like this, and then I'm going to write the prime factors of 54 now. 54, 2 goes into 54 27 times, 3 goes into 27 9 times, 3 goes into 9 3 times, and 3 goes into 3 once. Meaning the prime factors of 54, it's 3, so it's 2 3 cubed. 3 cubed. So what is the highest common factor? The highest common factor, we're going to look for a number that can go into 36 and 54. So we look for what is common between this. There is a 2 here, there is a 2 there. So there is only 1 2, and there's 2 2s there. So what is common? They both have 1 2. Or you write down the base and you take the one with the lowest exponent. So this one has 2 exponents, this one has 1 exponent, this one has 2 exponents. It's like saying one person has 5 rands, another one has 2 rands. 5 rands and 10 rands. Oh man. One person has 5 rands, another person has 10 rands. If I wanted them to contribute, maybe to buy something, I cannot expect 10 rand from this one because he has 5 rands. So I'm going to expect both of them to contribute what they have, which is 5 rand. I don't know if it makes sense. So here, they both have 1 2, that is common. And then 3, you take the compare them, take the one with the lowest exponent. So 3 2. So 2 multiplied by this is 9, meaning 18. 18 can go into both of this. My person. Okay, guys, we're here. No? Oh, we're here. We're here. So meaning the highest common factor between 36 and 54 is 18. 18 can go into 36, and then 54 can go into 36. Let's try another question. Okay. 120 and 54. So I'm going to write the prime factors of 120. You can use a ladder method or a tree method, whichever method you're comfortable with. 2 goes into 120 60 times. Remember, I can't put a 4 there, I can't put a 10 there because of I divide by prime numbers. So 2 goes into 60 30 times, 2 goes into 30 15 times, and then 3 goes into 15 5 times, and then 5 goes into 5 once. So the prime factors of 20 is going to be what? 2 1 2 3 3 5, right? And then for 54, 2 goes into 54 77 times, and then 7 goes into 7 goes into 77 11 times, and 11 goes into 11 once. So the prime factors for 154 is 2 multiplied by 7 multiplied by 11. So let's look at this one. We first identify what is common. Highest common factor, HCF. HCF, what is common? What is similar between this? So here we've got a 2, we have a 2. 3, there's no 3 here. There's no 7 here. 5, there's no 5 here, there's no 11. So this cannot be common because they don't appear in both of the numbers. So the only common base is 2. And then here it's exponent 3, here it's exponent 1. We said for the highest common factor we choose the lowest exponent between the bases. So meaning 1, meaning the only number that can go into 120 and 154 without a remainder is 2. We can do another example. Let's try another question where we have 3 questions now. Find the highest common factor between 102, 204, and 408. So what is the highest common factor between these 3 numbers? Okay. So same thing, I'm going to do prime factorization the way we've always been doing it. So I'm going to write the factors of 102 here. I'm going to write the factors of 204. I'm going to write the factors of 408 there. So 2 goes into 251 times. And 2 cannot go into 51. But 3 goes into 51 17 times. And 17 is a prime number. This is a prime number, so 17 goes into 17 how many times? Are we clear, guys? Okay. So meaning the prime factors for 102 is 2 multiplied by 3 multiplied by 17. Let's do this one. 204. 2 goes into this 102, and then it gives us this number, so we can continue with this. So it's going to be 2, 51, 3, 17, 17, 1. So for 204, that's actually going to be what? 2 squared multiplied by 3 multiplied by 17. So the last one, 408 divided by 2. So this gives us this one. So meaning we're going to follow the same pattern. 204 divided by that, it gives you 102. Divide this, it gives you 51. And then divided by that, it gives you 17. And then gives you 1. So the prime factors for 408 is 2 cubed multiplied by 3 multiplied by 17. There's actually a pattern there. If you can see these numbers, there's a pattern. Alright, so what is the highest common factor? I'm going to identify the bases that appear in all these numbers. So 2, 2, 2, 2 appears, 3, 3, 3, 3 appears, 17, 17, 17, 17 appears. And then I'm going to take the ones with the lowest exponent. So 3 and exponent 3 is the same for all of them, so we're going to take that one. 17 is the same, we're going to take that one. But for 2, here there's exponent 1, here exponent 2, exponent 3. So we have to take, for the highest common factor, remember it's vice versa. For the highest common factor, we take the lowest exponent because of it has to be something that appears in all these numbers. So here it will be 1. And then you can multiply it out, it will give you this answer, 102. So 102 can go into 102, 102 can go into this because we can see we got it there when we're doing our decomposition. And then 102 can also go into 401. So that's the highest number that can go into all these numbers. Okay, cool. Let's do LCM, then we're done. LCM, lowest common multiple. So let's do questions on that. The lowest common multiple. Write down the lowest multiple. Why did I write it in full? The lowest common multiple, which is called LCM, between the following numbers. So the first one, which is pretty straightforward, they say between 4 and 6. So what you do, you can either do it prime factorization way, or you can do it the long way, of which you need to find all the multiples, like few, or count the multiples until you reach the first common multiple between the numbers. So what are the multiples of 4? It's 4, 8, that's 4, sorry. What is 4 plus 4? It's 4, 8, yes. 4, 8, 12, 16, 20. Okay, I'm going to wait there. Go to 6. The multiples of 6 is 6, 12, 18, 36. So the first number that appears into both of this is going to be the lowest common multiple. 4 doesn't appear, 8 doesn't appear, 12 appears. That's the first number that's the first common number to appear. So you can either do this method, 12, or we do the letter method. Divide this, compose 2 goes into 4 how many times? Twice, and 2 goes into 2 once. So the factors of 4 is 2 multiplied by 2. And then let's get to this one. 2 goes into that 3 times, 3 goes into that how many times? 1. So the prime factors of 6 is 3 times 2. Alright. Okay. Now for the lowest common multiple, what do? We list all the bases. The first thing to do is to list all the bases. List all the bases that you have. So what are the bases? Here I have 2. Now go to the other one. What are the bases here? 2 and 3. 2 I've already mentioned it, labeled it. So I need to mention or list the one that I haven't listed. So which is 3. So I'm going to write 3. Now, the ones with the similar bases, I need to decide. So for the lowest common multiple, for the highest common factor, we were taking the one with the lowest exponent. And for the LCM, we're going to choose the highest exponent. We're going to take the base with the highest exponent. So which one is that? It's going to be, this is 2 squared, this is 2 to the exponent 1. So which exponent are we going to take? The highest one, which is that. 2 squared is 4. 4 multiplied by 3 is how much? 12. Are we all clear? So either way, you're going to get the same answer. Whether you use this method, which sometimes might be a long method, or this one. So either way, it's going to work. Let's do a few more questions. I'm going to do 2 more, and then we'll leave you guys to do the rest of the questions. You can ask if you have any question. 16 and 34, 15 and 40, 15 and 40, and then let me do one with 3 numbers. I want to do another one here, 42 and whatever. Okay, so this one, what is the prime number that goes into 15 without a remainder? Is 3. 3 goes into 15 5 times, 5 goes into 5 once. So the prime factors for 15 is 3 multiplied by 5. And then for 40, 2 goes into 40 how many times? 20 times. 2 goes into that. 10, 2 goes into that. 5 goes into that once. Is that fine, eh? So 40 equals to 2, 1, 2, 3 cubed multiplied by 5. So let's check that is correct. Then, for the lowest common multiple, we said the first thing is to list all of the bases. So here I've got base 3, base 5, base 3, base 5. Come to this one, base 2. Have I listed 2? Not yet. So I'm going to list 2. 5 is already there. So make sure you list all the bases that appear in your numbers, in your values there. And then base 3 is the only one there. 5, both of them, they've got exponent 1, exponent 1. This one, it has exponent 3, and that's the only one. So we're going to take that one. And then you can press that on your calculator. You get 120. So the first number to appear on both of the multiples of 15 and 40 will be 120. Let's do one more question. One more question. So I hope you get it. The trick is make sure you know how to do your prime factorization. Use your tree diagram method or any other method. From there, you use the same principles to answer the question. So 42 divided by what? By 2 it gives us 21. 3 divided by 21. 3 goes into 21. 7 times 7 goes into 7 once. So for 42 I have 2 multiplied by that. With togetherness. 84 divided by 2 gives me 42. This is similar to this. Can you all see? So I'm going to divide this by 2 to get 21, divided by 3 to get 7, divided by 7 to get 1. So the prime factors of 48 is 2 squared multiplied by 3 times 7. Then 100. Divide 100 by 2, you get 50. Divide 50 by 2, you get 25. Divide 25 by 5, you get 5. Divide 5 by 5, you get 1. So prime factors for 100 is 2 squared multiplied by 5 squared. Is that okay? Okay, so what is the lowest common multiple? We said the first thing is to list all the bases. 3. So I list all of this. Check. I've listed all of them except 5. So here I'm missing the 5. Then I'm gonna take the ones with the highest exponent. Don't forget 2, 2, 1. So I'm gonna take 2. 3. 1 is the highest exponent. 7. 1 is the highest. 5. It's squared. So I'm gonna take that one. Then what is the answer? Press that on your calculator if you can, because it's a big number. Okay, 4 multiplied by 25 21,000. You can actually do this without a calculator. Let me show you. We're going to multiply this together. 3 multiplied by 7 is 21. 2 multiplied by 5 it's 10. 10 squared it's 1,000. So that's why we have 21,000. Alright, thank you so much. All the best. Okay.